Welcome everyone. In this video I am going to talk about negative binomial distribution. So let's start. Consider an experiment where the properties are same as those listed for a binomial experiment. In case if you do not know this, you should watch the previous videos that for binomial distribution there is a process that the distribution should follow, and that is known as Bernoulli process. I will repeat here again for your convenience, but to get better idea you should watch the previous video. So let me repeat. Consider an experiment where the properties are the same as those listed for a binomial experiment, with the exception that the trials will be repeated until a fixed number of success occur. Therefore, instead of probability of x success in n trial, and that was the requirement for the binomial distribution where n is fixed, we are now interested. What we are interested in the probability that kth success occur on xth trial. Experiment of this kind are called negative binomial experiment. And what is negative binomial random variable? The number x, look at this carefully, the number x of trials required to produce k successes in a negative binomial experiment is called a negative binomial random variable, and its probability distribution is called negative binomial distribution. So just to highlight few important point, in case of binomial distribution I have told you that in each trial the probability of success remains same, or before that there was another property that every trial result into two outcome, either a success or a failure. So here also this will be the same situation, that every trial will be either a success or a failure. Second was that the probability of success in each trial, is constant. So P is constant in each trial. And third one was that the trials are independent of each other, means the outcome in the first trial will not affect the outcome in the second trial. So these properties are same, but in binomial distribution the first property was that we are repeating the trial n number of times, but here we are not fixing the n, we are repeating the trials till the time we get kth success in xth trial. So this x may take any number of value, because if we want to get kth success, listen, this is very carefully I am explaining this. Suppose I want to get kth success. So kth success may require how many trial? If you are very lucky and suppose you perform the first k trial and you get success in all the first k trials, right? So kth to k success to happen, it is possible that you have to perform the experiment k times and you may get success in all the k trials. But it is also possible that to get k success you may have to perform the experiment k plus 1 time, or you may have to perform the experiment k plus 2 time, or you may have to perform the experiment k plus 3 time. So here the experiment can be performed till the time where we get the k success, right? So what is the negative binomial random variable? The number x of trials required to produce k successes in a negative binomial experiment is called a negative binomial random variable, and its probability distribution is called the negative binomial distribution. I will explain it further, so let us move to the next page. What is the probability distribution for a negative binomial distribution? If repeated independent trials can result in a success with probability p and a failure with probability q, and you know that probability of success plus probability of failure should be equal to 1, so q will be equal to 1 minus p, then the probability distribution of the random variable x. And what is this random variable x? The random variable x is the number of trials needed to get the k success, right? So the formula for that is in binomial we use b, so here I am using b star. So b star x is the number of trials needed. What is x? X is the number of trials needed what is k? K is the number of success. So, and what is the p? What is p? So p is the probability of success in each trial, which is already explained, right? Now, ladies and gentlemen, what is the formula? The formula is x minus 1 ck minus 1 p to the power k q to the power x minus k, where x can take value k plus 1 and up to infinity. So let us understand this. First of all, suppose you are performing a trial and you want to get k success. So to get k success, how many minimum number of trials you need? Minimum number of trials you need is k, because how can you get k success in lesser than k trials? Because to get k success, you at least have to perform k trial. So the minimum value that this negative binomial random variable will take is k. To get k success, you may be required to perform the experiment k plus 1 time, or you may be required to perform the experiment k plus 2 time, right? If you are very unlucky, you may have to continue till the very end, means till infinity, to get the k success. So how do we basically obtain this formula? Just I am trying to explain. See, we want the kth success. So, and kth success is happening in x trial. So suppose we are getting the kth success here, and kth success is happening in which trial? It is happening in xth trial. So it means what? That before I got k success, how many trials I already have performed? Here I am performing the xth trial, means before that I have performed x minus 1 trials. And before I got kth success in this x minus 1 trial, how many successes have already happened? K minus 1 success have already happened. You agree to this? This is a very important discussion. I am saying that, suppose I repeat it, that I am getting the kth success in xth trial, means before I perform xth trial, how many trials I already have performed? I have performed x minus 1 trial. And in xth trial, suppose I got kth success, means up to x minus 1 trial, how many success I have got? I have got k minus 1 success, right? Now if you look at this design here, if I have to calculate the probability of kth success in x number of trials, so here x is the number of trial with the probability of success in each trial is p, this will be equal to what? So how many total number of successes are happening? The total number of successes happening are k success, and probability of each success is p, so it will be p to the power k. And what is the how many failures will happen? If out of total number of trials are x trials, and k success means there will be x minus k failures. Are you getting it? There will be x minus k failures. So the probability of x minus k failure, probability of one failure is q. So x minus k failure will be q into q x minus k times. So I am writing x minus k time. Now how does this x minus 1 c k minus 1 comes? It comes because if you have to choose k minus 1 success in x minus 1 trial, that can happen in how many ways? That can happen is in x minus 1 c k minus 1 ways, right? I hope this is a basic counting thing. I am saying, I am repeating this again just to be clear about the formula. What is this value x minus 1 c k minus 1? This is just the number of ways of selecting k minus 1 thing out of x minus 1 thing. So if we have to get k minus 1 success in x minus 1 trial, that may happen in how many ways? That may happen in x minus 1 ck minus 1 ways. Just to explain it better, suppose I say that I want to get two heads in three tosses of a coin. So two heads in three tosses of a coin may happen in how many ways? It can happen in this way: head, head, tail. This is one possibility. Another possibility is tail, head, and third possibility is tail, head, head. So in these three ways we are getting two success. So basically this is what? This is the number of ways of getting two heads in three tosses. So that is 3c2 ways. So that is why the number of k minus 1 success in x minus 1 trial will be given by x minus 1 ck minus 1, and kth success is fixed, means the last success is fixed because it is going to happen in the xth trial. So there is no possibility of selection there. The possibility of making selection lies in the first x minus 1 trials only. And I hope you also have understood that why we are taking the x value k, k plus 1 and so on, because to get k success you need minimum k number of trials. I hope up to this the things are very clear. So to make sense of it, let us do some problem solving. Solution: find the probability that a person flipping a coin gets the third head on the seventh flip. So first of all, be clear about the terminology. How many flips are there? X is equal to 7. How many successes are there? We want to get third head, and suppose getting a head is a success for me, so k is equal to 3. And what is the probability of success in each case? It is equal to 1 by 2, because if you toss a coin to get a head, the probability is 1 by 2. So they are basically asking what is the probability of 3 success in 7 trial. So we write 7 is the number of trial, 3 is the number of success, and then we write the probability of success 1 by 2. Some people can also write it for easier thing. If you have understood that what is x and what is k, then you can directly write that probability of 3 success in 7 trial. But be clear that this is the notation. So 7 is the number of trials, 3 is the number of success that we want, and p is the probability 1 by 2. So the formula was, what was the formula? I write again for your convenience. B star x k p was x minus 1 c k minus 1 p to the power k and q to the power x minus k. Yes, ladies and gentlemen. So here it will be what? X is 7, so 7 minus 1 c k minus 1, that is 3 minus 1. P, probability of success 1 by 2, 1 by 2 to the power k, so 1 by 2 to the power k is 1 by 2 to the power 3, and then q, that is also 1 by 2, and x minus k, so that is 7 minus 3. So you can see that here success and failure total will add to the number of trials. So what we get? We get here 6c2 and 1 by 2 to the power 3 from here and 2 to the power 4 from here. So I will get 1 by 2 to the power 7. So 6c2 can be written as 6 into 5 by 2 into 1 and into 1 by 2 to the power 7. So if you solve it, you get 2 in 3 into 5 is 15 by 2 to the power 7. If you want to leave the answer like this, fine, otherwise you can calculate it in decimal as well. Now what is the second part of this problem? Second part is, what is the probability of getting first head on fourth flip? So means you are performing x 4 times and you want to get the success 1 time, and probability of success is 1 by 2. So we can use something known as a special case of negative binomial distribution, but I am not using the term. I will discuss that later, but here I am using just the negative binomial distribution, right? So what is the formula here? We have to calculate b star x4 k1 and p, that is 1 by 2. For k is equal to 1, we will talk about a special distribution, right? So but right now I am not using that term. Now what is the formula? Formula is x minus 1, so that is 4 minus 1 c k minus 1. So k minus 1 is 1 minus 1. Probability of success 1 by 2, and to the power k. So how many success we want? We want just one success, and q is also 1 by 2, and we want how many success? We want 4x minus k. So I write 4 minus 1. So if you solve this, you will get 3 c0, right? You will get 3 c0, and here 1 by 2 to the power 4, right? So 3c0 is basically equal to 1, and into 1 by 2 to the power 4. So what we get is 1 by 16. So this is how we calculate the probability in case of negative binomial distribution. This is an interesting problem, and in NBA, National Basketball Association series, the team that wins 4 games out of 7 is the winner. Suppose that team A and B face each other in the championship game, and team A has probability 0.55 of winning a game over team B. So it means that P value is 0.55 and Q value is 1 minus 0.55, that is 0.45. The first question is, what is the probability that team A will win the series in 6 games? Now ladies and gentlemen, this is something which you need to understand very carefully. First of all, there is a rule that is followed in National Basketball Association series, that the team that wins the 4 matches first will be declared the winner. It means what? That you are expected to play 7 matches, but suppose team A is winning the first 4 matches in the sequence, means first match, second match, third and fourth, then it will be declared the winner, right? They are not going to play the 5th match, right? They will play the 5th match only when none of the team has won the 4 match, right? It is like I think this kind of thing happen, I guess, in super over. I am not sure. I am not following cricket from quite some time, but I hope you are clear about the rule that the moment a team wins the 4 match, that will be declared the winner. So the first part of question is, what is the probability that team A wins the game in 6 games? So basically x is equal to 6. Each game is a trial. If I can equate it to this, that each game is a trial, and if you are winning it, it is a success, or you are losing it, it is a failure. So x is equal to 6, and team A has to win the series, means it has to win the 4 matches out of 6 matches. So k will be equal to 4. And what is the probability of success? That is equal to 0.55. So what is the probability that we have to calculate using negative binomial distribution? B star 6, that is x, 4, and that is the number of success we need, and then the probability of success, that is 0.55. So the formula is x minus 1, so 6 minus 1, c k minus 1, that is 4 minus 1, and probability of success is 0.55 to the power k, that is equal to 4, and 0.45 to the power 6 minus 4, x minus I write 6 minus 4 so that you remember it. Now you have to kind of do this calculation. So 6 minus 1 is 5c3, and 0.55 to the power 4 into 0.45 to the power 2. I leave this for you to do the computation. I am writing and let me know the answer in the comment section. Answer in the comment section, right? That do this computation. If you have a calculator, or if you are watching it on laptop, you can also use the laptop calculator, but you have to give me the answer, right? You should not leave the answer like this in the exam. They will deduct some marks, so you should evaluate this and then give me the answer, right? Now let us talk about the second part of the problem, that what is the probability that team A win the series. Okay, now this is an interesting problem. What is the probability that team A win the series? Now to calculate the probability that team A win the series. I will suggest you to pause the video and solve it and then come back and verify that whether you are able to solve it correctly or not. I am giving you the solution. So in what situation team A will win? The rules tells you that a team wins the series if it wins 4 matches. So the first possibility is that team A may be very lucky. It plays 4 matches and it wins all the 4 matches in the first 4 matches itself. It is a possibility. Another possibility is that team A plays 5 matches and then it wins the 4 matches with the probability 0.55. Another possibility is that team A plays 6 matches and wins 4 matches with the probability 0.55. Another possibility is that team A plays 7 matches and then wins the 4 matches with a probability 0.55, because in total they have to play 7 games. Don't make the mistake. I hope you have understood this, that what is the probability that team A wins the series. So these are the 4 possibilities. To win 4 matches, either you have to play 4 match, 5 match, 6 match or 7 match. So for each of it we have to calculate the probability separately, right? So how can we calculate this probability separately? I am going to write the terms here and rest of calculation you can do. So it is 4 minus 1 C 4 minus 1, probability of success 0.55 to the power 4, probability of failure, that is 0.45 to the power 4 minus 4, that is equal to 0. I am writing just for you so that you don't miss the point. I could have written 0 directly also. Plus it is like 5 minus 1 C 4 minus 1, probability of success 0.55 to the power 4 success and 0.45 1 failure, so 5 minus 4. Yes or no? Now this one, so there are total 6 minus 1 C 4 minus 1, probability of success 0.55, 4 success, how many failure? 0.45 failure, 6 minus 4, that is equal to 2. And then the last one, so 7 minus 1 C, and here it is 4, so 4 minus 1, how many success? We want 4 success, and how many failures in that case? 0.45 to the power 3. So this is the thing that you have to do the calculation, and again I am leaving this for you to complete it and give me the answer in the comment section, that what will be the sum of all of it. So answer in the comment section. This computation I am not going to do because it will require the use of calculator, but I believe that you will be able to do it. Okay, now let us do the third part. If team A and B were facing each other in a regional playoff series, which is decided by winning 3 games, 3 out of 5 games, what is the probability that team A would win the series? Now they are just playing the 5 matches. So in this case, what is the situation here? The situation here is different. So the situation here is that X is equal to 5, right? And they have to win how many matches? They have to win 3 matches out of the 5 matches. Okay. So as you know the rules that and you have just solved the previous problem, here the rule is that if they are expected to win the series, they have to win 3 out of 5 games. It means what? That if they play first 3 match, suppose team A is playing the first 3 match and winning, then it will be declared the series winner. So sometimes if you don't follow this rule, you may be like thinking of using the binomial distribution. There is a small difference here, because the rule is saying that any teams who wins the first 3 match will be declared the winner, right? So to win the series, what is the possibility? The possibility is that suppose the team is playing 3 matches and it is winning all the 3 matches, the probability of A winning the match is 0.55. Plus another possibility is that team is playing 4 match, out of that it is winning 3 with the probability 0.55. And the third possibility is that it is playing 5 match and then it is winning 3 with the probability 0.55. So if I have to calculate it, how I will calculate? Again, x minus 1, so 3 minus 1, c k minus 1, so 3 minus 1. How many success? 0.55 to the power 3 success. How many failure? So 0.45 to the power 3 minus 3, that is 0 failure. Now it is 4 minus 1, c 3 minus 1, right? How many success? Total 3 success. How many failure? Total 4 minus 1, that is 1 failure. And then the last one is 5 minus 1 c and 3 minus 1, and then what is the probability of success? 0.55 to the power 3, and what is the probability of failure? 0.45 to the power 2. So you do this calculation and let me know in the comment section that what is the value that you are getting. Okay, so moving ahead, let us solve this problem. An item is produced in large number. The machine is known to produce 5% defectives. A quality control inspector is examining the item by taking them at random. What is the probability that at least 4 items to be examined in order to get 2 defective items? Now let us understand this problem very carefully. To get 2 defective items, it is possible that someone is selecting the first 2 items and it is defective, or selecting the first 3 items and it is defective, or selecting the first 4 items, it is defective, or it may continue 5 items, 2 are defective, 6 items, 2 are defective. But in the question they are asking that what is the probability that at least 2 items at least 4 items are to be examined so that we get 2 defective items. Means here this distribution, negative binomial distribution, the negative random variable x should take value 4 or greater than or equal to 4, 5, 6 or so on, because I want the negative random variable x to take at least 4 value, means because we want to examine at least 4 items. I hope you have understood this thing, that here getting a defective item is a probability of success, means it is a success, so probability of success is 5 by 100, that is 0.05. What is the probability of failure? So 1 minus 0.05, that is 0.95, right? And if I have to calculate that what is the probability that at least 4 items should be examined, so basically I want the random variable, this random variable which is known as negative random binomial random variable, I need to have this value either greater than or equal to 4. At least 4 means the same thing, means we have to calculate the probability for x taking its value equal to 4 plus probability x taking its value equal to 5 plus probability x taking its value equal to 6 up to so on. So the inspector who is examining the item may be very unlucky and he has verified hundreds of items and he is not finding any defective item. So basically it is not possible to calculate all those values, but since the law of probability, that this binomial which is the negative binomial random variable. And see, because we are quite used to use the term binomial random variable, so by mistake if I use binomial random variable, basically what I mean is negative binomial random variable. So if I want two defective item, means if I want two success, x can take its value greater than or equal to 2. To get two success, you must have to select two item. I mean, it will sound foolish if I say that I have selected two item and I got two defective item. Idiotic. So means minimum two item must be selected. Yes or no? So how to calculate that probability? So to calculate that probability, the required probability that x is greater than or equal to 4, I have to subtract 1 minus the probability for x is equal to 2, first two item defective, or plus probability for x is equal to 3, because the sum of probability for all x greater than or equal to 2 will be infinity, up to infinity will be equal to 1. So 1 minus this will give me all this value. Yes or no? It is just a simple thing. If I ask you, find the value of x4, x5, x6, it will not be possible for you, because x can take any number of value. X may take infinite value, right? So it is easier to calculate the probability for x is equal to 2 and x is equal to 3. So basically what we are trying to calculate, we are trying to calculate the probability for two trials, two success, with the probability of success 0.05. Then we are calculating the probability for three trials to get two success with the probability 0.05, right? So how to calculate this? I believe since we don't have the space here, I am writing here in the top just to change the color so that you don't get confused. So I am writing here 1 minus b star 2 2. So how you will calculate it? Total number of two trials, so I will write 2 minus 1, c here also 2 minus 1, and then probability of success 0.55 to the power 2, and no failure, because we want both success in the trial. So 0.45 to the power 2 minus 2, that is equal to 0. It was not needed, but I have written for your understanding. Plus what is this term? So 3 minus 1 c 2 minus 1, you want 2 success, that is 0.5 to the power 2, and in 3 trials you want 1 failure, so 0.5 to the power 1. So you just do this evaluation. If you do this evaluation, you will get the value 0.99275. Verify this and let me know that whether you are getting this value or not. I think it is making sense to you. The thing is slightly new, but still I hope you are getting it. So moving ahead, let us talk about the geometric distribution, right? And geometric distribution is a special case of negative binomial distribution, right? I could have made this comment in the beginning, but because some of the students may look for that where is the geometric distribution. Geometric distribution is nothing new. It is just a special case of negative binomial distribution where k is equal to 1. So in the negative binomial distribution, I was looking for kth success in xth trial. It sounds slightly tongue twister, right? Because we want kth success in xth trial, but here we just want the first success in xth trial. So we have simplified this. So the negative binomial distribution will change to what? The number of trial x, the number of success we want is 1, the k is 1, and the probability here is p. So earlier it was x minus 1 c k minus 1 and p to the power k q to the power x minus k, if you remember. Now if you take k is equal to 1, it will become x minus 1 c 1 minus 1, so that is equal to 0, and p to the power 1 success, so p to the power 1 and q to the power x minus 1. So if you simplify this, you know this basic thing that nc0 is equal to 1. So this thing basically will be 1, and here we get p, and here we get x q to the power x minus 1. So for this formula reduces simple. It is p x q x to the power p into q to the power x minus 1. I hope it is clear. And to get the first success, how many trials you need? You may get the success in the first trial, so x can take value 1. You may get the success in second trial, you may get the success in third trial, and so on. So the random variable x can take value 1, 2, 3 up to infinity. So this kind of distribution is known as geometric distribution. So you just look at this. The negative binomial reduces to this geometric distribution. So if repeated independent trial can result in a success with probability p and failure with probability 1 minus p, then the probability distribution of the random variable x, the number of trials on which the first success occurs, is written as gxp, p into q to the power x minus 1. So you can see here that here this k term has been removed because we are looking for the first success. So in spite of writing this negative binomial distribution, I am just writing geometric distribution, x trial with probability p, because we are looking for one success. So probability of success is p and probability of failure is q. So out of how many trials? Out of x trial, there is one success and x minus 1 failure. So the probability is p into q to the power x minus 1, and the name is geometric distribution because it will look like a geometric series if you expand it. Yes or no? If you look for the expansion, it will give you a sense of geometric series. So that is why this distribution is known as geometric distribution. To make sense of it, I am going to solve a few problems. So let us quickly solve the problem number 1. So what is the first problem? For a certain manufacturing process, it is known that on average 1 in every 100 items are defective. What is the probability that fifth item inspected is the first defective item found? First defective item. We are looking for the first success, not the kth success. So we will not use the negative binomial distribution. See, it is not the right thing to say that we will not use the negative binomial distribution, because geometric distribution is just a special case. But just for the sake of simplicity, I'll say that I will use the what you call geometric distribution. So what is the probability that fifth item inspected is the first defective item that we are going to get? So to solve it, how should we proceed? So let me explain you through this example again. So here, what is the probability of success? Probability of success is on average 1 in 100 item is defective. So finding a defective item is a success for me. So the probability of success is 1 by 100. And what is the probability of failure? Probability of failure is 99 by 100. Some of you, it is sounding slightly counterintuitive that finding defective is a success, but I hope you understand the meaning of success here, right? Now we want to calculate the geometric distribution. So what is the probability that fifth item inspected is the first defective item found? So here we are calculating x is equal to 5 and probability of success, that is p, is equal to 1 by 100. I hope you have understood this. We write the geometric distribution as g, x the number of trials, and p is the probability of success. So here we are actually looking for the probability of fifth item, means we are doing the 5 trials. So g 5 and probability of success is 1 by 100. So what was the formula? The formula was p, that is let me write it here so that you don't confuse. P gxp is p q to the power x minus 1. So here p is 1 by 100 and q is 99 by 100. So 99 by 100 to the power 5 minus 1. So what we get? We get, you just can simplify. I am not going to do all this simplification for you. Yes or no? You might be thinking that I am leaving all the simplification, but anyway, you can write it 1 by 100 into 99 by 100 to the power 4. If you have the calculator, complete it. Okay, fine. Go to the next problem. The probability that a person living in a certain city owns a dog is estimated to be 0.3. It is a good probability. Usually 0.3 probability means every third person, almost every third person is owning a dog. Do you love dogs? Put in the comment. find the probability that 10th person randomly interviewed in the city is the 5th one to own a dog. Now here I have taken a question which is not of geometric distribution. It is of negative binomial distribution. Why? I hope you have understood it. Because the probability of owning a dog, if I consider it as a success, is 0.3. And they are asking find the probability that 10th person randomly interviewed, means I am performing the trial x is equal to 10. In the city is the 5th one, and I want the 5th person, that is k is equal to 5, to own a dog. Owning a dog by someone is a success for me. So even though I talked about geometric distribution in the previous problem, this is not a problem of geometric. We have to use the negative binomial distribution. And again, I hope you notice the difference, that their geometric distribution is just a special case. So we have to calculate B star, the probability of 10 trials with 5 success with the probability 0.3. So that is x minus 1, 10 minus 1, c k minus 1, 5 minus 1, probability of success 0.3 to the power how much? We want 5 success, so 0.3 to the power 5. What is the probability of failure? 1 minus 0.3 and to the power 10 minus 5, that is also equal to 5. So ladies and gentlemen, if you simplify it, you will get 9c4 0.3 to the power 5 into 0.7 to the power 5. And if you simplify it, I could have left it for you as an exercise, but let me give you the answer. It will be 0.0515. Verify it. More problem coming. 3 people, this is a good question. Good question. 3 people toss a fair coin and the odd one pays for coffee. You can play this game, right? You can play this game. And if the coins all turn up the same, they are tossed again. Find the probability that fewer than 4 tosses are needed. Pause the video, think about it. What they are asking. I am proceeding. 3 people toss a fair coin and the odd one pays for coffee. So if you toss a fair coin, it will, the possibility may be that all of them may get a head, or possibility is the outcome may be like this, or the outcome may be like tail, head, tail, and head, tail, tail, or tail, head, head, or tail, head, tail, or tail, tail, head, or tail, tail, tail. Odd one pays the paid for coffee, means what is the probability of success here? The probability of success here is that if you are tossing a 3 people are tossing a fair coin, if this one comes, we have to repeat the experiment again, because it is written if all the coins turn up the same, they are tossed again. So in which situation I have to toss the coin again? In this situation, let me highlight it with black color, this situation and this situation. In all other situations there is a success, because if 3 people are tossing the coin and the third one is the odd one, so this one will pay for the coffee. In this case, this gentleman will pay for the coffee, the second gentleman. In this case, the first gentleman or lady, I mean it is a a gender related issue should not be there, lady or gentleman, whatever, people, because they are people. So in this case this man will pay, in this case this man or women, or here this person will pay. Okay, so the probability that a person will pay the bill or odd one will stand, so there are total 8 outcomes. Out of that, 6 outcomes are there in which the game will stop. There will be a success. The game will stop means there is a success. You get the first success. So it is 6 by 8, that is 3 by 4, because there are 6 outcomes which is associated with someone has paying the bill for the coffee. In these 2, the experiment will be repeated again. So the question is, find the probability that fewer than 4 tosses are needed. So means we have to find the probability that the negative random variable x actually takes value less than 4. Fewer than 4 tosses are needed. It means someone is tossing, 3 people are tossing the coin, and in the first toss itself someone is coming out to pay the coffee bill, because that may stand out, or some odd one will have to pay. So we can calculate the probability, that what is the probability for x is equal to 1 when just one trial happens. The second one is, what is the probability, and see, this is a case of geometric distribution, because when you are playing this game, what is happening, the moment you get the first success, the game stops. You go and buy the coffee, and the one who has been odd has to pay the bill, right? So you are looking for the first odd outcome. If you are getting head, then you will toss again. If you are getting tail, then you will toss again. So the probability that in first toss itself by the 3 people the game will be over, we have to calculate that. Then we have to calculate the probability for 2 tosses, means everyone has to toss the coin again. And then we also have to calculate the probability for 3 trials, means these 3 people have to toss the coin again. So what is the probability for 1 success, means this is the probability for getting the first success with a probability 3 by 4. Then probability of getting the first success in 2 trials, so G2 3 by 4. Then probability of getting 1 success with 3 trial is G x is equal to 3 and p is equal to 3 by 4. I hope you are not getting confused. I quickly repeat. What is the game? 3 people are tossing a fair coin, and the odd one pays for coffee. So if you toss a coin, these are the 6 possible outcomes. If this outcome happens, the toss will be done again. Otherwise, someone has to pay for the bill. So if you calculate the probability out of 8 outcomes, 6 outcomes are resulting into the success. So the probability of success is 6 by 8, that is 3 by 4. And the moment we get the first success, we complete the game, go to buy the coffee. But the question is, what is the probability that fewer than 4 tosses are needed? So I am calculating the probability that in first toss the game will be over, we will get the first success. In the second toss we will get the first success, and in the third toss we will get the first success. So that is, this is representation of 1 toss with a success, 2 toss with 1 success, or 3 toss with 1 success. So that is how do you calculate 3 by 4 p to the power 1 into q, that is 1 by 4 to the power 0. And you can see common sense also, that if I just ask you that what is the probability in the first toss itself the game will be over, that probability is already 3 by 4. In 2 games, so the first time, the first one will be 3 by 4, it will be a probability of success and to the power 1, and probability of failure 1 by 4 to the power 2 minus 1, so that is also equal to 1. And then 3 by 4 into 1 by 4 to the power 3 minus 1, that is 2. So if you simplify this, how will you get? Let me solve this. You will say that sir is solving the easier one. So 3 by 4 plus 3 by 16, yes, and plus 3 by 64. So if you solve 64, this will be like 48 plus 3, 48 or something, how much, 16 3 ja 16, 64 into divided by 4, so 16 3 ja 48, 64 divided by 16 is 4, 4 into 3 is 12, and plus 3. So how much we get? We get 63 by 64. So it looks like that we are going to almost the probability equal to 1 in the third trial itself. So it is very, very likely that this experiment will not last for more than 3 trial, because you can see that probability that the game will be decided in 3 trial is almost equal to 1. So it is almost going to be a certain event. So I hope you have understood the things, right? In case you liked the video, you can buy me a coffee. How to buy me a coffee? That I will let you know. Yes or no? Anyway, I was just joking. So that is all. I'll be doing the Poisson distribution in the next video, and after that I will create a video in which, and that video will be a long, because in that video I will talk about moment generating function for all the distribution, because that is also something that is the part of your syllabus: binomial, Poisson, normal, and all the distribution. So thanks for watching and have a great day.